Hi, hello, good afternoon. Just going to have to play with the audio levels a bit. All of these lecture rooms, again, are frustratingly different. Goody. Okay. Hi, welcome all of you. It's good to see a bunch of people here today. We've got what, like 4, 8, 12, 16, 32, 33 perhaps. So we've got our Slido up and our YouTube up as always. I think this is even more important today. So I will be probably leaving this up for a lot of the lecture. So my friends over here, do your best to look over here. If not, maybe a good time to move. Just so we can get feedback from people online as well as those who are here in person today. Now, we have 16 people tuned in online, so we've got about 50 students here today. I'm here because Yuchao has asked me to come and talk to you today about iteration 2. Yuchao isn't able to make this particular lecture during the term, so I'm basically here to help answer any questions people have about iteration 2 and to get you settled. So there's no active content today or anything like that. Should probably hit record. So if we just look at the agenda of today, it's quite literally, that is not what I'm looking for. I'm looking for a particular repo. So iteration 2 was rolled out to groups, I think, sometime on Saturday, Sunday, from what I was told. And you should have it in your group repo at the moment. Put your hand up if you have read through iteration 2. That's excellent. Good job. About half the room at least. There's going to be more that just couldn't be bothered to put your hand up. Put your hand up if... I've just got to move this mouth. Is audio choppy? I'm getting some choppy audio from people apparently. Oh, okay. Maybe not. Audio's okay. Put your hand up if you've started iteration 2 with your group. Who's done some work on it so far? Who's tried to write code? Okay. Another small handful of people. Cool. Well, that's a good start. So what I'm going to do is I'm going to try and talk through it a little bit, maybe for like 15 minutes, just to set the landscape a little bit. And then I will we'll spend the rest of the time answering questions. So we got a 2-hour block today. Once I've kind of said the main things I'm going to say, we're just here until the questions stop from you or the Slido or YouTube, right? That's the drill. Could be half an hour, could be 2 hours. We will see. Now, many of you have seen the iteration 0 and 1 pre-records. For the previous iterations, I recorded those, I think, back in like January, February. So I'm a little bit, I may miss a detail or two, but 99% of it should be OK. Now, iteration 2. You obviously had me to put up with last week when we talked about building web servers. And iteration 2 is all about building web servers. The best way I can explain iteration 2 to you in a nutshell is that iteration 2 is you take iteration 1, which was just functions being called, and you now do the same thing, but instead of just functions being called, it's a web server where those functions are routes, and then you double the functionality. That's iteration 2. So it's conversion to a web server, then double the functionality, because iteration 1, there was only so many things it could do, right? Whereas there's a lot more functionality in iteration 2. Now, I'm just going to kind of skirt through this in little pieces. And what I've got here is I've gone and cloned the project backend locally on my computer. This is just the course one, so it's the templated thing. There's nothing kind of done about it. I'm just setting up an npm install. Many of you would have already done this. And we're just going to go through all the different points in the for section. The first one is iteration 2. It says running the server. So in iteration 2, you run the server by simply typing npm start. And when you type npm start, it will start up the server like that. npm start, you will find, if you look inside the package.json, is just running this command tsnode-t source/server. Sorry, it's npm run that. So that's the actual... Did I not npm install properly? Or is tsnode? Did they remove tsnode? Oh, no, it's there. That's weird. Yeah, it's probably just... Let me just do this real quick. So what is actually being run here is, instead of using node, we're using TS node. You know about that. The dash T, I don't think we really talked about that last week, but the minus dash capital T, it basically turns the type checking off. So when you run TS node with the dash T, it basically says, if I see any TypeScript errors whilst I'm trying to compile and run your code, I will ignore them. It's a really common thing that's used for development. And all it does is simply strip out the TypeScript and run the underlying JavaScript. And the reason it's quite common in development is because it's much quicker. Notice when I hit enter here and I run that, it starts up pretty quick. But if I get rid of this, you'll notice that it will, well, you probably don't notice it there. There's not much code, but it's a little slower, right? If I compare that to this, it's like much quicker, a little quicker. In larger pieces of code, that can be quite an extensive amount of time. Like if you have a large code base and you try and run it without the TypeScript skipping thing, it might take like 10 or 20 seconds to actually start up the server, because TypeScript checking can be quite a heavy process. So that's the npm start. It's quite literally just running a node file, which we added to your repo in the source folder here called server.ts. And server.ts it's got a bunch of stuff in it, but if you try and just focus on what's in between these lines, it's basically a server with routes in it. And the only route you have for iteration 2 is the echo route. Right? The echo route, you would have seen that for iteration 1. Echo takes in something and sends it back. It echoes what you give it back to yourself. And you can play around with that if you'd like to. A lot of the stuff above this line isn't super important, and a lot of the stuff below this line isn't super important either. Most of the reason it's above and below the line is to just separate it out, because all these things around cores, that relates to network security. This relates to error printing. This relates to the displaying of the docs. This relates to some helpful things for students. This is to do with shutting servers down in the case of getting an exit command. As I said to just the newcomers over here, I'm going to leave the questions up on this slide for a lot of today, just because it's a question-heavy day. So if you're struggling to read that, it's a good time to move. Otherwise, let's just get settled. So that's the server file. So we tell you, OK, you can run the server, and if you have a port issue, you go run it on another port. All right, 4.3, implementing and testing features. This is a carbon copy from a previous iteration. All it says is that in this iteration, just like iteration 1, you will be writing your tests and then the implementation. So you write tests, you commit it, you write implementation, it passes the test, you put that in. Nothing new there. So I don't really have anything to unpack, because just the lack of information. This one is a little bit heady. What this one is saying with 4.4 testing the interface, it's basically saying that in iteration 1, you were writing functions, and then you were writing jest tests that were calling those functions. In iteration 2, because we have a web server, you're not going to be calling those functions anymore. What you're going to be doing is you're going to be calling the routes on the server. So if I have a look here, what I mean by that is, for example, this echo here might have been something you see in iteration 1. It's a function, right? Function is called, really easy. But in iteration 2, we actually have a route called /echo. And what we're saying is that in iteration 2, a lot of those tests you would have written like this one, right? This echo test looks familiar, no doubt. You don't need those anymore. When I say you don't need them, I don't mean you should delete them. I just mean like they're not going to contribute to your test suite, because what you will be doing instead is this, which is instead of testing your echo directly, you'll be testing it by calling the HTTP part of it. So you're writing an HTTP server and you're testing an HTTP server, as opposed to writing functions and testing functions. We'll unpack this a bit more, but the good part of this is that in reality, what often happens, as you'll see in the server here, is notice how with the server, what the echo route is doing is it is simply calling the echo function that we imported from our echo file. And the reason, if you're not sure what I mean, you can always read up on this later. But what we're saying here is that this is what you wrote in iteration 1, or an example of it, an echo function. And we're saying in iteration 2, this isn't about rewriting everything. It's about repackaging stuff. Or sometimes we refer to it as wrapping stuff, which is that you take your server, and all your server is doing is actually calling that function anyway. So all that stuff you wrote in iteration 1 is, you need it. It's being used in totality. It's just that instead of calling it directly, it's being used by the HTTP server. So if you say had 12 functions in iteration 1, for iteration 2, you will now have 12 routes, at least, and each of those routes will call a relevant function that you've already written. So in a lot of ways, for half of iteration 2, you've done the hard work. You've done what we call it the business logic sometimes, which is like the logic specific to an application. To do with like checking email and checking if the user's already registered. That part's already done. It's just not in the right HTTP format. So that's what that section is in relation to. 4.5 is a note. These are all like random notes. I'll come back to that. Continuous integration. Yeah, so Yuchao would have talked about continuous integration in week 3, I think, probably. That's where it was the whole, like, you can automatically run jest and other things. And in that as well, Yuchao would have talked about, basically would have said this will come up eventually, and it probably then came up in your week 4 labs, right? You had the little tick cross in your lab up on GitLab. If you're not sure what I mean, it's the little thing up here, like that little thing. And then come lab 5, you'll see that too, and come iteration 2, you will also see that. You will see that in our iteration 2, we actually only have one thing there for you at the start, which is running your tests. So basically, when you push stuff up to GitLab now, it will run the jest, like it'll just run npm run jest for you automatically, and it'll give you a ticker across if it passes. Remember, this just emulates what's going on the terminal. So it's not like some extra kind of test. You could do the exact same thing on the terminal. And what we're saying in this next section is that you can add more to this if you'd like to. That's really up to your group. Good examples are linting and type scripting. So like npm run ESLint or npm run TSC. You can add those to the pipelines if you'd like to the continuous integration jobs, or you can leave them out and just like do them on the terminal manually as you go, right? And this kind of is useful because for a lot of groups, you might not do anything with TypeScript in iteration 2. Or with linting, you might not lint your code till the end, right? Has any groups figured out what their plan is on linting yet? Probably not. Yeah? Put it in our pipeline, yeah. So you want to keep the code linted the whole time. That means you're just doing a lot of little bits of work rather than one big chunk of work at the end. Sounds good. I know sometimes other groups leave it out till the end, though that can also be messy. I generally recommend people put it in early like that because it makes you think about it, because at the end of the day, you're here to learn something. And usually what will happen realistically is that, and it's also a bad look for your tutor if they look at it as, if you leave it right till the end, you'll probably just get one person to go and clean up all the code, and then that doesn't really look that good in terms of everyone learning the same thing. Yeah?
I'm confused because it's bad practice to submit like a famous pipeline, but we need to commit our tests before we commit the function, which is on the table.
That's a great point, yeah. So it's like, when I make my tests, but not the implementation, my tests fail straight away. But the pipeline is checking my tests if they pass. So the way around that is actually this little thing we've got here. So what this does here is this says that we only actually run this code, this particular test code, when a commit's put into master and when there's a merge request that's created. So if you're, say, on a dev branch and you do a few commits and stuff, the pipeline won't actually run for that job, the test job, until it actually ends up in a merge request. So you kind of imagine you do like a few test commits. OK, you got your test done. You do a few actual implementation commits. No pipelines are run on that. But then when you go and create the MR, that's when the pipeline gets run, and hopefully by then it's all packaged together. Yeah, so the two parts to that is that if you don't push the tests, GitLab runs on every commit that's pushed. So if you do 5 commits locally and then push, it runs it only on the last one. However, when you add this as well, even if you pushed every single commit, it will still only run it in those conditions. So you could push every commit as long as it's not on master or it's not a merge request. That's a great question. So thank you. Yep, so you can add the linting and the TSC if you'd like to. TSC, most of you probably won't want to add at this point, but linting, I imagine, will be quite common. For this iteration, we do ask that you store things persistently. UChow should have also done the lecture on persistence. Was it on Monday? I think, yep. In that particular case with persistence, it's really quite straightforward. What I'd say to you all, though, is that persistence makes debugging a bit easier, too. Because in iteration 1, you had so little stuff. You know, you could just kind of run it. But in iteration 2, because there's more routes, when you're debugging it, in particular using one of those API clients we talked about, where you're going to register a user and do this and do that, it's really actually useful having the server maintain its state when you turn it off and on. Because otherwise what will happen is, like, imagine that you go and you register a user through an API client, then you go and create a quiz, and then you do something and it doesn't give you what you want. So you go update your code over here, and you have to restart the server because you updated your code, but now all the data's gone. So the persistence is actually, don't just see it as like a box to tick. That's actually something you should do early on because it'll save you a lot of time. Because again, iteration 1 was small enough that you could just rely on jest. And you need to write tests for all of this, but debugging will be bigger in this one. You will actually want to use the API client to kind of poke it and play around with it because it will be hard to test everything just through automated testing. Yeah. Yeah, you can leave your server on for however long you want, for sure. Yeah, that's not really an issue. It doesn't really consume any resources. It just kind of sits there waiting for a request. Also, the course website, this is also built. I built this over summer. This is a Express server as well. So, at the end of the day, we try and do that a lot in some of these courses. Is what powers this is the exact same thing. So every time you send a request and stuff to it, or you open a new page, that's just another request to that Express server. So it's a very, very common world. This isn't something super vague that's happening. I already talked about versioning at the end of the week 2 part 2 lecture, so we don't need to talk about that. User sessions, there is a little bit to unpack there, so we'll come back to user sessions. Error returning, we'll come back to that too. Okay, next couple things. Working with a front end. So one of the cool things about iteration 2 is because it's a web server, it can actually work with a front end as well. And what we've done in the course, what some tutors maintain, is a front end repo. And what you can go and do is you can go and clone that repo if you'd like to. And you can actually start it up. All you have to do is follow the instructions here. It says run your backend on port something. So let's imagine that I'm running this on port 3200 right now. Let's imagine that I go to my config file and change it to, what was it? 49153, like that. OK, tick. Clone this repo and cd into the new folder. We did that. Run npx http server -p 3000. I forgot to run my server. Yep, so my server's running. That's running. And now what they're saying is that if I load up this URL here on my computer, that, oop, didn't really like that. Am I running something else? That's strange. Let me just check. It's strange that the contract's there. Did I run that in the right folder? Oops. Sorry, ran that in the wrong folder. That's what it was. I was like, that looks a lot like your major project. So this is me actually running this locally on my computer. And the way it works is that this front end here that we built for you some time ago now, it will actually talk to your server. Like your server on your computer. So this is a front end running on my computer with a server running on my computer. Right now it's not going to do anything because when I go to register like that, it's going to be like route not found. It's going to have a complaint there. You can see it's actually trying to talk to my server. Me fiddling around with this is not required knowledge, but if you see, oops, oh yeah, sorry. But if you see here, if I go to register and I click this, you'll see that it actually tried to talk to the server there. Here, it tried to talk to the server, v1, admin, auth register. It tried to call a route, but I haven't implemented that route. Now, neither of you, right? It's not, you haven't done it yet in iteration 2. And because you haven't done it, the front end's not going to work. So why the front end's cool is that, well, there's a couple reasons. One is that as you're working on this, once you do more stuff in your iteration, it's pretty exciting that you can actually see how your code's panning out, right? Because you should be able to play a game at some point, or at least do some functionality. The second thing about the front end that's really cool is that when it comes to iteration 2 marking, auto marking is not something many people get above 90 on. There are two reasons for that. One is what you'd expect. They don't finish their implementation or they rush something and it's buggy. Okay, sure. The second reason, though, is that you misunderstood the spec. This one's pretty common. Some of you might have been bitten by this in iteration 1. Did anyone pass 100% of your tests in iteration 1 but not get 100% on the auto mark? Have you got your auto mark back for iteration 1? You'll discover that soon, I guess. But some of you will have passed all your tests for iteration 1, but you might get like an 82. And you'll be like, why did I get an 82? We passed all our tests. And the reason are because either you missed some tests or because your tests were actually testing the wrong thing. Which is kind of why we talk about testing is so important. Because like if you read the spec and you write a test that tests the wrong interpretation of it, then you can lose marks. So the reason the front end's also useful is because it's kind of set up in a way that is how things should largely work. So particularly for some basic things like register and login, if you run the front end and you can actually register and log in with your back end, that gives you more confidence that things are working fine as well. Yeah, so yeah, that's the front end. You can run that. That I don't know. I'd have to talk to UCHR because I'm not sure what her plans are, but I don't think it's required that I'll read the marking criteria, but I don't think you need to use it to get marks there. This next part, example implementation. There is an example implementation of the front end and back end as well that you can play around with. So if you kind of want to see what your web server is building towards, then you could come here and you could go register this user. Someone's already used that. You can log in. You can see a bunch of quizzes. I can go and create like a quiz called hello. And now there's a quiz called hello. And I can add a new question to that quiz, things like that, right? So this is an actual front end that is powered by an example implementation of the back end. Specifically, it's powered by, I think, a random group from 23T3 that I got a tutor last term to fix up. So this is an actual group has written the back end for this. So course writes the front end, group wrote the back end, and it all functions as a nice little app where you can go play quizzes and things like that. So point of this is mostly to maybe get an intuitive understanding of how this all pieces together. There's not really any like mark value in looking at it. It's more like if you're struggling to picture what things mean or do, it's really useful. So that's what that's for. Recommended approach. A recommendation with this iteration is you start out trying to, so I've talked about this before. You should try and clean up a lot of your iteration 1 stuff into HTTP and then focus on the new things. We'll talk about that when we look at the actual docs though. So marking criteria for this iteration is also pretty similar. You have your auto marking component. It also includes linted code this time. Cool. You have your test quality, your general code quality, and your Git project management stuff. I don't think this is very different. So I don't think this should be any much of a surprise. Okay, it looks like they do want you to get the front end working. Now, the criteria says like demonstrate the front end working. I want to kind of point this out because it's somewhat a meaningless request, because if your code is passing your tests, it's going to pass the front end. Do you know what I mean? Like, because if your code works, it works, whether it's a front end or jest test. And the reason the front end's interesting is like if you're getting like 100% in your jest test and the front end is working bar one random bug, I wouldn't think about it too much, because there are tutors who maintain the front end, and like sometimes there's a bug or two in the front end. But my point is, like, if you're passing 100% of your tests, but you can't even register on the front end, or you can't even create a quiz on the front end, then like that's a great point of reflection for you to go, maybe we've screwed something up and don't realize it, and you'll go review that. But besides that, the criteria here is largely the same, but of course read it. Just like iteration 1, they mark you by multiplying what percentage of your tests you pass against what percentage of the course tests you pass. So same thing there. It's just that that's now, instead of 100% of the mark, it's 95% of the mark, and there's a 5% linting component. So the linting is just 5% of the auto mark there. Important note, and I don't think UCHR will have changed this term, but historically there are no partial marks for linting. So you either get the 5% or you don't. The reason for that's actually really simple. there's no excuse for you not to lint your code, if that makes sense. Like, you know you've linted it. There's no mystery there. There's no auto mark. Like, it's such a simple request for you to get the code linted, because sometimes students come back and they say, oh, well, we only missed 3 things. And it's like, yeah, but you knew that before you submitted it. Do you know what I mean? Like, you'll know what your linting mark is before you hit submit, because everyone in your team just runs npm run lint on your terminal, and you see there's errors or there's not. And if there's not errors, you're like, we got the marks. Great, we move on. If there are errors, you didn't get the marks. That's kind of how that one works there. There's a dry run, just like the previous one. There's a peer assessment, just like the previous one. And then everything else, typically, there's leaderboards, just like the previous stuff. There's plagiarism. These things are at the bottom because they're not particularly new. They're just kind of, sorry for scrolling so quick. They're kind of just same old, same old. Like leaderboard, auto marking, managing issues, peer assessment. Nothing new there. So if I just now that I've kind of talked about it a little bit, actually let me maybe talk about this bit first. This part here, swagger.yaml. So swagger.yaml is the page that shows you all of the stuff you have to implement for iteration 2. In iteration 1, we gave you a big table in the spec. In iteration 2, we've given you this kind of other doc kind of thing. This is a standard document format that's used quite commonly to describe HTTP servers. It's where you can just kind of see everything that needs to happen in an HTTP server. You'll notice here that there's 2 sections. There's one called iteration 2 using iteration 1, and there's one called iteration 2 new. Everything here in this iteration 2 using iteration 1 part, these are all routes that basically use functions from iteration 1. And if you have a look, you'll notice that. Put user unless something's changed and no one told me, right? Put user details, put password, get the quiz list, create a quiz, delete a quiz, get a quiz, update a quiz's name and description. That's all still part of iteration 1, right? I think. Yeah, okay. All of you like, I don't know. So what this means is that, let's take something like user quiz details. What the docs say is that there needs to be a route, a get route, called /v1 admin user details. And what happens is it takes in a token, which we'll talk about in a sec, and it returns a structure like this. Now, my point is, for iteration 1, you would have written a function that returns all of this. You know? So for iteration 2, for all these routes here, all you have to do is basically go to the server here and start going app.get, what is that? v1 admin user details. v1 admin user details. Copy the other one here. Normally, I would just copy and paste this. You don't need to write it out like I'm doing it. And then I would say, well, it's a GET request, so I fetch things from the query. If you're not sure what I'm talking about, just go review last week's Wednesday lecture. I know that I don't actually take in anything in this case, except a token. Token is like auth user ID. Remember auth user ID? Yeah, so let's just call it that for the moment. Request.query.authUserID, but it's actually token. Come back to that. And then you say, well, actually, I had a function in iteration 1. And what I'm going to do is I'm going to export that function and then import it here. So I'm going to go import now admin auth register from, I don't know what file you called it. I think it's like auth, like that. And then you would say, well, actually, and what does auth return? It returns from memory an auth user ID and a, it returns that big object of stuff. Let's call it like big object. And then I would just call, I don't know why I imported admin auth register. I'm sorry. Some of you are probably like, what's this guy on about? Admin user details from, say, user. Does that sound better? Yeah? What file did you put your admin user details in? Also in auth. Sure. I'm sure some of you put it in a few different places. But you've got that function from iteration 1. So now all you have to do is say, well, I'm just going to call that, and I'm just going to pass in auth user ID, like that, say. I'm kind of, giving you the gist of it. And then, well, what are you going to do? You might just return big object. Now, I'm not trying to write the exact code for you here, because there's a little bit of nuance, and I'm not trying to take away the learning experience. But my point is, that's the gist of what you kind of have to do for iteration 2 for those functions. Now, let's also imagine, my point, that you had some tests, right? And this one might be like auth.test.json auth.js. Right, so you had some auth tests from iteration 1. Okay, well, what you do now is you basically go, well, let's see what's happening here. You can go take the tests that we've given you in new echo, and instead of doing this, you can just go and like literally create some more tests, look at this HTTP part and be like, all right, well, we got to call v1 auth user details. We're going to pass in, what was it? Add, auth user ID over the URL or something. You don't have to worry about a timeout. You can leave that, it doesn't really matter. And then you return it, then you just check if the results are the right thing. Again, I'm glossing over that lightly. My main point here is, well, the only difference with iteration 1 is just quite literally the difference between new echo and new echo test. Because the echo is maybe not the best example because it's quite a simple function. But you see here, all echo does in iteration 1 was it was just, where is it here? All you do is you call echo and you check the result to be 1. Okay? In iteration 2, you're just calling echo and you're just expecting the result to be hello in this case. I could change this from hello to 1 if I wanted to. It's the same thing. So really look at these two files closely, because these two give you a really good idea of the difference between testing in iteration 1 and iteration 2. And my main point again is that testing, instead of calling the function, you simply have to make an HTTP request and capture it that way. So in reality, you'll notice that this line is very much the same. Not identical, but very close to being the same there. Now, the point with these iteration 1 routes is that they require fairly minimal adjustment. Your tutors will often referring to it as like you have to wrap the iteration 1 functions into routes. Iteration 2 new stuff, though, is actually whole new things. These are functions you haven't seen before: logging out, trash, restore, empty, transfer a quiz, add a new question. A lot of the question stuff is actually iteration 2. Creating a question, updating a question, deleting a question, moving a question, duplicating a question. So lots and lots of question stuff. For these, you will actually write all the code for it. But the cool thing is you can use the stuff you've done in iteration 1 by saying, well, if I've got this here, like let's say I've got a new function, admin quiz, quiz ID question, and that's a post. So I go app.post, b1, admin, quiz, quiz ID question. I copy and paste that. What you'll do is something similar where if I look at that and I say, well, what does it take in? It seems to take in a body, a big fat object here. Because when you create a quiz question, you've got to give it a lot of information, right? Like what's the question, what's the duration, what's the points it's worth. You can go read up on this. But it takes in a quiz ID and that. So I can see that the quiz ID is passed in via the path there, right? That's this thing here. We covered that last week. That's just one way of passing information into a route. But the rest of this is passed in via the body. And I can see that there's a couple of different elements here. One's called token, one's called question body. So I could very quickly capture those and say, well, I know my quiz ID is actually just request.path.quizid. These two things match here. That's what that wildcard is. I know my token is request.body.token. And I know that my question body is request.body.questionBody. Because remember, request.body is this whole object here that's passed in, I think. Or it might be body. You have to play around with that a little bit. Do you have a question?
What's the difference between putting something in the path and in the query string?
Yeah, so the quick recap is that if you have a URL, say like this, and you say, let's say you define it, page intro name equals Hayden. So this information after the question mark is the query part. And sometimes you can capture more information as a wildcard in the actual kind of like path before the question mark. In this case, like there's two ways you could do this. One is you could do it like that, or you could capture that information like this in the URL. And when we capture it like this way, the way we write it with Express is that we kind of use this little wildcard here. So the equivalent of this one, if I was writing the route, would be /page/intro/name, and then I would capture that later and say request.path.name, which would, if I said const name equals that, then that would give me Hayden if I called page intro Hayden.
So why don't we have both if they're like the same?
That's a good question. Like, it's a great way to think. It's like, well, what's the point of having both? There must be a difference between them, Largely, there's not. This one is kind of more like old school. So like the original functioning of the internet would be that you would have a particular route, like something/something, that would represent a literal file on a literal web server, and everything after the question mark was like the dynamicness of it. It was like the data you passed in. But I think it would have probably been mostly driven by Google, was that people realized that having a website, say you got google.com/ or like unsw.edu.au/page, and then you just have like Jarbly after that. It didn't look very pretty to people, but also Google was a bit punishing for it, because what Google would pick up on is that you were definitely parameterizing your stuff. If you want a really good example, so the company that I run, we have this way of comparing different financial products. And what you'll see is that up here in the URL, it's kind of got this like explore, invest, compare, and then it's got this stuff here. Another way that could be written instead would be like item 1 equals that and item 2 equals that, right? That's another way to parameterize that. But the reason we don't do that is because Google, if it sees this, it's immediately like, oh, that's actually just one page. And when I see all these different combinations of it, I know that you're just like spamming that with many different possibilities. Whereas when Google sees this stuff, it's usually a little nicer on it, and it assumes that might be an actual unique page, because Google likes a website that has a lot of unique content. It doesn't like potentially like automatically generated stuff. So that I think just became quite a popular way that people would build websites, and then people who write web servers started to provide that as well. So functionally, it's really not much different, but that's like the broad background of it. Cool. So yeah, let's say you're doing this post quiz question thing. You would capture, this is how I want you to think about these routes. You basically do 3 things, which is like capture, call, and return. So I would capture all the information that I need, some out of the path, some out of the body, and then you'll go and you'll write another function just like you're doing iteration 1 again. And that function might be called like admin quiz question create, right? And what data might be passed into that might be a token in the question body. Or you might need a quiz ID. You write a function like this. You can do that any way you want. And typically, what is that going to return? Well, if I look at the docs here, you can see that this particular route needs to return a question ID. Because when you create a new question, it needs to give back a question ID to the front end. So I'm going to say that my admin quiz question create function will return a question ID like this, and then I will simply response.json question ID. Now, think about black box testing from week 2. I haven't written this yet, right? I don't know how to implement that yet. But the point is that I will go and do this in another file, like maybe a question or a quiz.ts or that, and I'll just go write it like this, Did I do that wrong? I did. That was really weird looking. I'll go and write my function like this, and it's going to go and like do lots of stuff. It's going to check the token. It's going to look up the data store. It's going to create a new ID. It's going to return a new ID, just like you were doing iteration 1 stuff. The reason this is important is because you can get into really easy structured habits that make iteration 2 quite straightforward, which is that you've got your routes where you've already done the logic for it, and you just need to HTTP wrap it. And then you've got all these new functions, like question create, where you can go write the logic for it, just like you did in iteration 1, and then the route for it. Now, in reality, you probably want to do those 2 things at the same time, just because of how tests work. Because in iteration 2, you're going to be writing tests for the HTTP level, like that. So you'll write your tests for the route, and then maybe you'll go implement that. My main point here is like, what a lot of groups will do is they'll go and write all the logic out in the server file, all the like data store stuff, and that can make your server file really complicated because basically you've written your whole program in like one file now. So I'm just saying, use the fact that you've got this nice separation between logic over here in one file and the server quite tight in the other. And the reason I mention this kind of capture, call, return approach, that's not some like, documented philosophy. That's just me making up words. Is that you can think of your HTTP server as literally trying to capture HTTP properties in JavaScript variables, call a JavaScript function, and return JavaScript variables as JSON back out to the world. And that's what your whole server file is. And your server file will look a lot like that, probably. Just a lot of capturing stuff, calling a function, returning things. And that becomes the entirety of iteration 2, in essence. This will take more time, but like I'm not exaggerating. Like you as a group, like these functions up here, these register login details, you should really aspire as a group to have those absolutely out of the way by Monday at the latest. And yeah, that's a little ambitious and stuff, but my point is that in terms of actual work for someone who knew what they were doing, this here should take about 10 to 20% of the time. Now, all of you are still trying to get used to the whole express and testing and jest and stuff, so it's going to take you longer, but that's not because there's a lot of work there, it's just because you're getting comfortable, And that comfort might make it take like a third of the time, or maybe for some groups like half the time. But that's only because you're not comfortable with the methods. But this stuff here is easy, because you're not actually solving new problems. You're just refactoring code, basically. Swagger docs are super useful. They're really descriptive. Yeah. All right, so I said that we talk about a couple things after, namely 4.5, 4.9, and 4.10. So what were they again? 4.5, testing time-based properties. Yeah, so all this one's really talking about here is that, I'm just going to pull up the Swagger docs again. When it comes to some properties like question create even actually, or is it question? I can't remember which one it was. Maybe we did that from iteration. Was there a route in iteration 1 that had like a time in it? Like list quizzes. Sorry? Update password. Yeah. I think I'm just trying to figure out why they've got this in the spec here. Because there's going to have to be, oh, okay, there we go. That's what I'm looking for. So when you look up a particular quiz in iteration 1, you would have had to return this object here. Now in iteration 1, this object wouldn't have been so big because we told you in iteration 1 to return questions as an empty list, right? Because there was no questions in iteration 1. But one of the things you had to return, remember the whole Unix timestamp thing? Remember that from last week? What we're saying for iteration 2 is some routes will have timestamps as properties. The tricky things about timestamps are like, sometimes they can vary in terms of like, particularly when you're sending stuff over the network. So what we're saying is when you're testing timestamps for iteration 2, I don't know, was this in iteration 1, this section? Okay, not sure. But it's okay to check that the timestamp's within a 1 second range. So if you expect a timestamp to be like 1, 2, 3, 4, 5, 6, 7, 8, then what we're saying is that like, you can, when you're checking it, it's like, let's say you're doing that. When you write your tests, instead of saying like, if time equals, this number, we're saying that you can check if time is greater than, say, that, and time is less or equal to, say, that, right? It's within a second either side, that's okay. It just helps, like, from a testing perspective that sometimes like you might have to call your server and your computer's network card has a moment because you're downloading some big file on the internet and then your tests suddenly fail. because aligning those timestamps can be quite tricky. You can just check times be what you want. That's fine. There's no issue with that. It's more just like if you ever find weird things happen with passing times, you can give yourself kind of a leeway. Some of you might be familiar with that from like floating point precision errors with like deltas and things. I don't know if that's taught in 1521 or anything anymore, but regardless, you can do something like that. So that one's pretty comfortable. 4.9 and 10. So this one's also relatively easy, and I did also talk about it last week, which is that when you respond to your server, when something like this happens, right? Oops. You know, when you call your function and your function returns you the question ID, you'll do your response.json to send the package back with JSON. However, sometimes what your server might do, because I guess a lot of the way we write these functions, right, is it's more like your function returns an object, and that object contains a question ID. That's probably closer to what you do. You also know that sometimes you check things and you say, hey, actually if, and I don't remember the best way to write this, but it's something like this, right? If there's an error on your object that you return, because you sometimes return errors in iteration 1, right? You give me real blank faces and it scares the crap out of me sometimes. That seems normal? Yeah, okay. What you do instead in this case, right, is that you might, so your code, if I'm really expanding it out here, it might actually look a little bit more like this, which is that you have your response.json there, but if there's an error, you actually say response.json error object.error, like that. Now, you might be thinking, they look like really similar lines of code. Sure, they're hard to compress, but what's really important here is that you throw the relevant status code like this. When there's an error, we don't just want you to send a message back, we want you to send an HTTP status code as well. Now, important, there's all those status codes that we've talked about. There's only 3 that matter, and you know the best part, we write them into the spec for you. They're all written right here. So every single route can only return certain status codes under certain conditions, and we literally tell you when to do it. So there's not a lot of mystery here. There's just a bit of fiddling with the code. And the other cool part is that even though there's 3, there's only really 1 a lot of the time, because the 401s and the 403s are always the exact same thing. Every single route throws a 403 if the token, maybe we should talk about tokens first, but a 401 is if the token is missing, basically if the auth user ID is missing from the request. And the 403 is always like if the auth user ID is there, but it's just for the wrong person. You know, like if user A creates a quiz, user B can't edit it. So the 401 and the 403 statuses, the errors that they represent, are always the same in every route. So there's not a lot of like figuring out what they refer to. You kind of can do it for one route once, and then you can kind of copy and paste the code or use a helper function or whatever. Most of the routes that throw interesting errors are throwing a, where is it? Surprised that one doesn't have an error on it. Most of them are throwing 400 errors. So what I mean by that is nearly every single error that you would have thrown, or when I say throw, I mean like have returned in iteration 1, was a 400 error. Because a 400 error represents when the client, the person who's calling your function, gives you shit, right, that you don't want. That you're like, that's not good. I can't deal with that. So all this stuff about name contains invalid characters, names less than 3 characters, names already used, description, blah, they're all just 400s. So this isn't some big scary thing. The majority of the time when you're capturing errors by your functions, you're typically just going to be a status 400 there. And this will either be 400 or 401 or 403. The message actually doesn't matter that much. The way our auto markers will work is they will actually check for the status, not the message, a lot of the time. So like if there are typos in your error or something, like it really doesn't matter. They'll just check like, is there an error message there, regardless of what's in it, and have they put the right status there? It also means when you're writing your tests that you should be checking statuses too. We give you a little bit of this also in the new echo.test.ts file. Lots of helpful stuff in the repo if you look for it. And this one here is just saying, if I call echo with echo, because if you remember the definition of the echo function was that it would return whatever you gave it, except for echo itself. And if you gave echo echo, it would return an error. So the same thing represented here. If you're writing a test in an HTTP land to test if the echo function is working right, you make the request, the GET request to echo, you give it echo, and then you expect that the status code that's responded with is 400. So that's the way to test it. And you don't have to separate these things out too, right? Like a lot of groups, they'll come and do something like this where they'll just check that 200 is the right thing. Now, I know I said there's only 3 status codes, but just to be really clear, there's 4 that you need to think about for this iteration. This one is everything okay. This one is bad input. This one is like no or damaged token, basically missing token. And this one is like token exists, but for wrong person. And again, think of token as auth user ID, which is the last thing we're going to talk about in my spiel today. Cool on that? It's all recorded at least today. I hit record, right? I did. Yep.
So recording, will it release on Friday or will it release after the lecture?
What was the first part?
Recording for this lecture, will it release after today or?
Yeah, I usually go and upload it straight away. I'll be on campus too, so it'll go straight up. Campus internet's very quick. Good question. All right, last thing. This one just takes 5 minutes to explain. User sessions. Okay. Now, I do think I wrote this section, and I tried to be really descriptive of it. And you have the benefit of, this is like the 4th version of it, and the first 3 I think weren't very good. And it lays it out, but I'll give you the quick summary. Here's the problem with auth user ID as a concept. Let's say you have an auth user ID. Okay, now you have a function like quiz admin quiz create. It takes in an auth user ID and maybe a name of the quiz, right? Simplicity. Okay. Auth user ID, you get one of those when you call register or login. So register or login both return an auth user ID. So they give you a number. What's the problem with that? There's a few problems with it, but I'm sure a bunch of you have figured that out or thought about it during iteration 1. Yep. Oh, sorry. Yeah, if you want to go anyway. Yeah, there's never a reason to log in, right? Because let's say someone gives you a user ID, you don't ever need to log in again because you could just always send requests with your user ID. It's kind of like, imagine if all you needed to log into someone's website was their driver's license. All you need to do is see their driver's license once, get the number on it, and be like, oh, okay, that's who you are. There's no password to Service New South Wales. I just need your driver's license number. So once anyone gets it, they can just use it, and also you don't really need a password because you can just type that in. Imagine, and maybe a better way to explain it is imagine if all you needed to do to log into a website was enter your email or pass your email in when you're making the request. The reason this is a bit tricky to understand is because it essentially has to do with how requests are sent over a network. And what I mean by that is that when your web browser talks to a server, like Netflix, right, it says to Netflix, I don't know why I always pick on Netflix, but it says I want to watch a movie, right? The Crown. Who's seen The Crown? No one's seen The Crown. I just started it recently. It's okay. It's you say, I want to watch The Crown. You send a request to the server, and that request will typically contain a secret password in that request, right, in the body. And that goes to the server, and the server sees that password and goes, oh, okay, I can tell that you're Hayden. Cool. I know it's you, so I'll give you your stuff. I'm sure it's not some random on the internet. I can tell you're logged in. If all I had to send Netflix was my user ID or my email, then Netflix would really kind of never have a way to log me out, for instance. Because how can you actually get logged out? Because if all I'm sending them is my email, how can they log me out? Because I just say I want more video and I just keep sending them my email. So what we really need is some kind of proxy for that, which allows us to basically manage sessions. what I really mean by sessions is like, you know, when you log into a website, let's say you log into YouTube on your phone and you log into YouTube on your laptop. When you do those two things, both times when you go to log in, you have to provide your email and password, right? Normal. But when they give you back your equivalent of an auth user ID, it's not your user ID. It's not your email. It's typically what we refer to as a session ID. Maybe like a pass number. You know, think of it like a boarding pass. You can think of it 100 different ways, right? Ticket into a concert, something, lots of different stuff. It's not saying, and like if you have a boarding pass on a plane or a ticket to a concert, this isn't saying, oh, this represents you as a person. It's saying this represents that you as a person have access to this thing right now. And someone could revoke that, right? You could have 3 concerts you're going to in a week, and you could tear up the first ticket but still get the second one. You could technically buy 2 concerts at the same time and have valid access to both. Someone could rip up one ticket but not the other ticket. It's basically like a pass in there. And the reason auth user ID isn't good is because you just can't do all of that. Because you give someone their auth user ID back, what's the point of logging in again? Because you've got the auth user ID forever. So instead, what we need service to do is actually return you a session. The session just represents like your time here. So let's imagine that I'm Hayden and I call auth user login, right, with my like username and password. If I call it once, I should get a random session ID, call it 654. If I call it a second time, I might get another session ID like that. If I call it on my phone, I'll get another session ID like that. And why that's useful is that what this allows the server and the application to do is that, let's say I'm now on my laptop or my phone, I can log out on my phone and not my laptop. Or if you want to, you could just log everyone out at the same time. So take again, just like the company I run, we have customers logging in all the time. They log in on their phone, they log in on their computer, they get different session IDs for different devices. If we think suddenly, oh my God, there's a bug, a security bug with the mobile app, what we could do is we could go and delete all of the session IDs for everyone who's logged into the mobile at once. And next time they go to log in, what happens is they send the session IDs to the server, but the server's like, that isn't valid. You know, and I guess the way to put it is like, if you right now with iteration 1, if you someone calls login to you and you give them their user ID back, how can you ever tell them to stay away or that they're not logged in? Is that even possible? It's like, no, because they just say, here's my user ID. What does logging someone out mean? How would you log them back in? You don't have that information because all you're capturing is the ID. So it's probably better explained on the page that I wrote. But what we do in iteration 2 is we basically just, instead of returning an auth user ID, we return a session ID. Does that make sense? So a user A, like Hayden, might now have a session every time they log in. Because I know how your admin auth login function probably works, right? Like you have your, you look up, like, does the email exist? And if it does, you say, like, does the inputted password match the stored password? And then you say, if both of those are true, you do what? You like return auth user ID, their ID, something like that, right? So, some variation of that in terms of code structure. What we're saying is that now, when you go to log someone in or register, instead of just returning their user ID, what you'll probably do is here, you will say, I'm going to create a new session ID. And that might be like some random function you call. Like, how do you guys generate user IDs right now? Is it random? Is it incrementing? Someone tell me one of them. Both? Incrementing, right? So somewhere you've got a global variable that you just increment. Is that what happens?
Just like based on the size.
Yeah, OK. Size of the users. Yeah, sure. So you could do the same thing if you wanted to now. There's a bunch of different ways you could do this. You could either have like a global variable called like sessions, which is 0, and every time someone creates a new session, you just increment it. You could do something similar where you look at the size of a list, you keep like a sessions array where you store all the user IDs in it, or you store random session IDs in it. Probably the easiest way that people will do stuff is like if you have your data store, what do you have in that now? Users and quizzes? That's kind of what it looks like, I imagine. What you'll do with the users is that when you say someone goes to register, admin auth register, I just can't write functions for the life of me today. say someone is registering and they give you their email, password, and name. Once you do all the checks, when you do your like users.push, or is it an object? Is users an object or an array? Array, okay. When you say users.push, what you might be doing here is you might push their like email, which is from the parameters. You might push their password, which is from the parameters. You push their name, and then you'll also push, say, a sessions array, like that. So for each user, you'll keep track of the sessions. But just before you register that user, you might say session ID equals create session ID. Now let's just pretend that this function here returns a random number, right? Just for simplicity. So let's imagine I have another function, and all that does is return random number here. Or like, returns generate random number, some function somewhere. Look it up on NPM. And then what you say is, well, actually, once they're logged in, like once they're registered, I'm actually going to create a session ID for them. Just imagine it as the number 1, 2, 3, 4, 5, 6, some random number. And then I add it to the sessions list here. So now for each user, I'm keeping track of the sessions that they've joined as well. And then when someone logs in, you know what? I do the exact same thing, which is that I create a session ID. And then I just happen to also look up like the user or like users and that user ID dot sessions dot push that session ID too. So my point is, if someone registers, we create a session ID for them. If someone then logs in 5 times, we create 5 more session IDs for them. So every time they register or log in, they're getting a new session ID. And now what you'll see is that your login function won't actually return a auth user ID anymore. It'll return something like a session ID. Because the person who gets the response from your register or login function, they don't need their user ID. That should be irrelevant to them. All they need is that session, that pass, that boarding pass that they store on their end. And now whenever they call the functions, quiz create, quiz details get, update password, they're not passing you their user ID anymore. They're passing you that session ID. And then if you have a function like quiz details or something, right? Now that function will instead take in a session ID and a quiz ID or something, right? Previously, it might take in a auth user ID and a quiz ID. And now what you'll do, there's a bunch of different ways you could do this, but a really dumb way you could do it is you could just say, well, you know what? For const user of users, or like whatever it is, data store dot, I don't know how you access that. That's your data store of users. Then you say for const session of sessions. You just say if session equals session ID. You basically loop through all the users and all their sessions IDs until you find one that exists. And you know what? If you can't find a session ID in any of the users, then that's an invalid session ID. Could be a random one. The reason this is useful too is because when you go to implement logout, which is a function later on in iteration 2, all logging out really does is simply delete a session ID that exists. So if someone's like logged in and they say, I want to log out now, all you have to do as a server is take their session ID and get rid of it. So, the concept, once it clicks, it's quite straightforward. Like, it's very intuitive, but I might have butchered some of the explanations of it. Now, where things get confusing is I've done these examples with auth user ID and session ID, and you see in the spec it has tokens, right? And I really need to stress this. In the spec, you will see this word token everywhere. Token here, token there, token everywhere. You have an idea of an auth user ID. You get that. Tick. There's also the idea of a session ID. I think you get that. I see some heads nodding from what our explanations were. What a token is, and this is, I think, where all the confusion happens. A token will typically describe a string that is passed around HTTP methods to identify a user. It is purely a JSON object that contains identifying information about a user. What a token will typically be will just be an object that contains a session ID that is JSON stringified. And the reason I explain this is, like, when I said here that you'll return session ID, you know that what your functions will actually end up doing in the server, right? Like if you have something that's like, app.post v1 auth user auth register, admin auth register. If you have something like this, at the end of this, you'll say response.json. You might have something like this: session ID is session ID, which you've gotten from up here somewhere. The stringified object is what we call the token. The token is purely a string that an HTTP server sends back. What is inside of that doesn't really matter. You could, if you wanted to, if your group chose to, you could actually return a token that contains a session ID and an auth user ID. That's actually a valid approach if you'd like to. So your comments before around, what's your name? Esther. So your comments, Esther, around, we just use the user's length to figure out what the next user should be. You could try and do something similar for iteration 2, where each user has a sessions array, and every time you add a new session, you just check what the length is, right? Yeah, and one problem you'd have to think about that is like it's very hard to delete sessions because then the array length changes. But let's imagine that you don't delete them for some reason. You could just increment it and go like session 1, 2, 3, 4, but then different users might have the same session IDs too, right? Well, a way you could get around that is that your token, instead of just containing a session ID, could also contain a session and a user ID, because with those two pieces of information, you could identify them. So back to the semantics of token, I just want to stress, a token is just a string that the server returns that contains the identifying information. So you know who that person is, what they're trying to do, the sessions and stuff like that. It can contain whatever, but the most two common things you'll see it contain will either be a session ID or both a session ID and an auth user ID. Either of those two things would be referred to as sessions. If you ever hear your tutor say something like, what's the token ID or something, that's just them using quick language to describe what's the ID of the identifying information within the token, if that makes sense. But token, just an HTTP thing. If you're not sure, if you're really lost there, every time you see token, just think session ID, and that'll simplify it down for you a bit as well. Hey, we got our first question for today, which is good because I have run out of things to say. Ghost of Blaze said, does that mean that every other function that uses admin auth ID as parameters has to be changed too? Yes. So there is some mild refactoring of iteration 1 that needs to happen. I didn't mention that at the start because I didn't want to scare you before we'd understood it. But yes, what it does mean is that if you have iteration 1 functions, that maybe if we can go back to the iteration 1 table, where is it? Up here. We're not going to take a break today because I don't think you're going to give me 45 minutes of questions, knowing you lot. You're like the least questiony people I've come across. Here you'll see like every one of these functions that isn't register and whatever, they take in an auth user ID and something. Yes, it does mean that like any time you see auth user ID from iteration 1, you'll need to change that to be token. Yeah.
Would it be possible to, instead of doing that, like changing all the parameters and into tokens, to add an intermediate layer inside our server, so that, for example, we create a separate sessions array. So we have, for example, if we receive an input token, we translate that into a user ID for our own use inside the function, so we don't have to change the function.
Yeah, sure. What's your name? Yuru? Excellent. That's a great point. So 10 steps ahead, you'll have a very comfortable time with iteration 2 by the sounds of things. So I love that question, which is like, look at this function we wrote earlier here. This was kind of my like, your iteration 2s will look a little like this. And your question, which is a great one, is, Hayden, what if I don't want to change my function to take in a token? What if I instead want it to take in just like an auth user ID like iteration 1? But what I'll do instead is I'll simply have something above here that kind of like, say, takes the token and it extracts the user ID out of it, Or like, for instance, it's like, okay, well, I know that there's a session ID in the token, token.session ID. I know there's a session ID in there, and then what I'll use is I'll use like a helper function that'll be like auth user ID equals like get user from session, or something like this, where you use a helper function to go and like grab that user from the session. And what you do is you check as well. You're like, if auth user ID returned like null or undefined or something, that's how you deal with the error case. Because naturally, someone might give you a session ID that doesn't correlate to a user ID. And in that case, then you do like your response.status 401s .json, error invalid token or something like this, right? And then what you do is like you do a little bit of this pre-filtering, if you will, such that by the time you get around to your function now doesn't have to worry about tokens or sessions or any of that stuff. It's just concerned with the core logic that you were doing in iteration 1. So you can preserve all your functions in iteration 1 and just like do some pre-work, right? Totally fine as well. A lot of this stuff is very open-ended in terms of what the right approach is. It's a fun thing to discuss with your group. This is really where you kind of get into the areas of software design. I think Yuchao talked about software design. That was the Monday lecture, right? Software design and persistence. Yeah, okay, cool. It's like the way Yuchao would have described it, it's like that's the interesting part, is asking yourself, like, what's the way to write this that makes it the easiest to work with later? The cool thing is you can always change code pretty easily. Like your project might feel really big, but in the grand scheme of things, like you could change the code up in your project pretty easily. And the cool thing, if you've written tests for stuff, if you have a test suite for your entire thing, changing code's really easy because if you screwed it up, if the tests start failing, Because like you go do big refactors and then all the jest is just tick green. You're like, wow, like we did that, everything's working fine. But yes, this would be totally fine as well. In some ways, I'd nearly probably say, like, if you had to ask me to pick between one of the two, it's really tough because I guess, like, yeah, I don't even know if there's like a specifically better way, but it's really up to your group. If you do put the token here, all it does mean is that the checking of the token and the session IDs and stuff just has to happen within your functions. And if you do it not there, it just has to happen within the server. Yeah. I'd probably say, like, if I had to give you the absolute... I get worried when I say stuff because if I say here's like maybe the best approach, a lot of you don't want to think about it too deeply and you just be like, just do what he said. So I say this with caution, but like if I was being a purist about it, I'd say the best thing to do would be to get the session ID and the user ID like out of the token in the server. Depending if you want to do one or two, let's just pretend you're only getting the session ID out. It would be to get that out of the token and then pass the session ID in here. Because like from a really fundamental software design principle, a good way to think about your server file is that it should be concerned simply with the translation of application logic to HTTP and back. So a server, something hits the server, it's all networks, HTTP, tokens, paths, bodies, queries, and JSON and stuff. You kind of decode that into just like something agnostic of everything you learned last week. You call your functions in a very like HTTP agnostic way that deals with the data store and stuff, and you keep the data store far away from the server file. Like separation of concerns is a common concept, but I'm being really finicky there, and I wouldn't think that deeply about it, particularly not to start. And I tell people this, because I have engineers that work for me, right? And usually what I say to them is like, when it comes to software design, if you can, in your head, picture how you would write all the code, like if you know immediately right now how you're going to get to the solution, then what you should do is think about how to design it. But if you don't actually know how to get there, which many of you wouldn't for this iteration, right? It seems like this big problem, you don't really know how to solve it. If I said to you right now, you've got 3 hours to do it, you wouldn't get it done in 3 hours, right? If I asked the 1531 students from last term, they could probably do it in 3 hours, not because they're smarter than you, but because they've done it, so they kind of get it now, right? So they can picture it very quickly in their heads. If you can't picture what you're going to do in its entirety, I generally recommend that you just start. Just start doing it, whichever way is obvious, whichever way is straight away intuitive. And at some point between starting and finishing, maybe 10% of the way, 90% of the way, it'll click. You'll be able to see the rest of the journey. And then at that point is when you stop and you ask yourself the design questions. Because it's really hard to get designed right if you can't picture the rest of it. Because otherwise all you do is you do something and then you learn more and then you're like, well, that initial design was really terrible. And that's where you get into the over-engineering problem. So don't overthink it, just kind of start. Yeah.
Do you think you could do an example on how to implement persistence?
Yes. Did UCHAR do one on Monday?
I don't think so.
Okay. So let me see what I have floating around. What would it have been? Maybe I don't even. The persistent stuff is thankfully really easy. It's just that, okay, just because there wasn't code on the slides, she probably just wouldn't have done any coding. Got it. So basically, let's bring this down to nothing. I'm going to reset my whole project that we've worked on today because we haven't really done anything useful. Oh, it's not even saved. Okay. Sure. All right. So really, really simple stuff. Let's imagine I have a server here. I'll just write the code. I won't fully test it. But how I would approach it is, let's imagine that you have your data store. The easiest way, when you think about persistence, there's two things you have to do. You're trying to save your data to a file. And I think Yuchar would have mentioned that, like, persistence, like, there's many different ways to do persistence. And typically a live system wouldn't try to be storing stuff in a file. It would be trying to store it in like a production style database. But for the purposes of this course, it's really easy to store it in a file. So how to think about it is one of the easiest things is, well, let's imagine that every time you call, do you guys call set data or do you just update the data directly most of the time? Set data? Okay, cool. So let's say you're calling set data. One way around it, potentially, is that what you do is you say, well, when it comes to every time someone calls set data, what I'm going to do is I'm going to simply open up a file. I'm going to call that file database.json. Now, I don't know how to write this off the top of my head, so I'm just going to Google it. Yep, file data options. Oh, really easy. So I say, yep, I want to write to that file json.stringify new data. Really simple, right? I take, every time I call set data, that's obviously all of your data that you call set data with. You JSON stringify it so it's a fat string, really fat string sometimes. And then you simply put it in a file in the file system. Now, I can show you how kind of straightforward this is. I don't even need anything fancy. If I just open up a node interpreter on my computer, I could write, I'd have to write it the old school way. But if I import file system and then I just go file system.write file sync, test.json, and then I give it json.stringify, and then I'll just give it some random object with A and B. Unless I've really screwed it up because I've never done this before. It should just create a file called test.json. There's the file, right? So it's a one-liner. Okay, now this makes sense. Every single time someone updates any data in your system, you just keep writing it to a file system. That's the first half, yeah? Oh.
I was going to ask in what case you would have to access that. Because the reason that you're storing it is in case of like a shutdown in the middle of it. How would you know to access that?
Yeah, that's a good question too. So when, because many of you with this thing, you've done something here, right, where you've done like users, you did this, right? You modified data store, is that what you've done? So a way to do that is, let's unpack that for a second. I'm actually going to set data to be null if I want to. And then the first time maybe someone ever calls get data, I'm going to make it really simple for myself. If someone does that, then I'm just going to read from a file, database.json. That'll return me, I think, the data call it like raw data. I need to, processed data. JSON.parse it because it's going to be a JSON string. And then I just simply set data to be processed data, like that. Oh, my computer's out of memory. Great. So that's one way to do it, because then like your data's like, when your server starts up, data's just null, and then the first time someone tries to access it, you're like, oh, crap, we don't have anything, so we're going to go and try and load it from the file. That's kind of manageable, but where things get funny is that the first time this happens, or when someone clones your repo, that file doesn't exist. So if you try to run the server, it's actually going to give an error, because it's going to try and open the file and it's not there. So sometimes what you can do there is wrap it in some kind of like, if raw data equals null or something, then what you actually do is then you set data to be kind of like, this is where you actually put that original stuff you had up the top, like users and quizzes. You'll do like that. And then suddenly you've now got a case where it's like, yeah, okay, if you ever call it and it's empty, you try and load it from a file. If you can't load it from a file, then you just populate it to a default, and that'll only ever get run once, because data's only ever going to be null the very first time. Some people, like honestly, I've never written it like that before. I think in previous terms, whenever I've had to explain it to someone, I usually put it in the server, but randomly I was just realizing it kind of makes more sense to just be in this file. So, because we've told students all kinds of things over the terms. Like sometimes we've said you can put it in a timer where every like 1 second it just like saves it. That could be fun. You could, because I'm not sure in data store, do we tell you can't touch it? You should modify this above. Okay, that's probably why. I don't think it matters. The fact that I've said that today is fine. You could go and modify that. I'll tell the tutors that I said that's okay. You want to modify data store, that's okay. If you want to modify it in server, we sometimes tell people to save it with a timer. Sometimes we said at the bottom of every route to put like a save function there. If you want, though honestly, I'm just genuinely saying that after telling students that for a while, it's kind of dumb. It's probably the smartest place to put it's in data store. It's just no one's probably done it because of this code we wrote here that was like, don't touch it. Yeah, it really doesn't matter. As long as you're saving it somewhere and loading it somewhere, it's all variations of the same concept, which is save every so often and load it at the start, and if it's empty, set it as a default. Also, I guess a good point to mention is don't forget, this is really important, don't forget to add it to your git ignore, because you don't want people committing your database, because otherwise what happens is like someone adds random code to the server and then they push it up, and then someone else like pulls, and then master's got different data in it, and then you get a merge conflict in a file. So typically like how the workflow would work is that you will keep database.json off the git, git ignored. And if someone was like, let's say you are working on your code and you're like, I'm getting a bug, and then your team member tries to reproduce it and they can't, your team member might be like, hey, can you send me your database.json just so I can have the exact same files that you have? And then you might shoot that across Microsoft Teams or something, right? And just copy and paste the file or something like that. But definitely add it to the git ignore. Yeah.
Regarding the token section.
Yep.
So when we write tests, due to the fact I did implement session ID token in 2 different ways.
Yes.
We can't really write tests for 2 different ways. We can only write it for one of the 2 methods. So how would we tackle that? Because we have to test other people's implementation as well. Theirs might be different.
I don't think you have to test other people's implementation, just your own.
Really? Because they said that we have to consider that there's a chance that we could have taken other people's implementation.
Sure, I understand. I imagine that that's probably said in the context of like the way to think about black box testing, but also to kind of sidestep that whole thing, just like your tests in iteration 1 probably never actually checked. Like, I don't know how much of it went through because I wasn't here for those weeks. But typically what you do with iteration 1 is you don't really check that the auth user ID is the right thing by checking the value directly. You call register and then you call login later and you compare them and you say are they the same, and that's how you check it. It's a very similar thing with the token. So you never actually, like, your tests never actually need to like inspect the token, so to speak. They can just say, well, I logged in over here. And even then you can't even test that because the tokens will be different. But yeah, you don't have to go into that level of detail with the testing. Cool. Any other questions today? Yep. Yep. Oh, well, okay, cool. What are you actually buying when you buy a domain for a website? I like that question because I still ponder that to myself at night, actually. Because I don't know. I actually have the same question. I know that quite often when you buy a domain, you're kind of like more leasing it in a way. Like, because there's a company that kind of owns the domain. Maybe like, GoDaddy's a really common one. And when you go to that website and you buy the domain, you don't buy it like you buy a car. You actually pay a yearly fee for it. So when someone says I buy a domain, typically it means that I acquire ownership. Just like it doesn't make sense. It really is like renting. It's like when you rent a house or an apartment, you like say, okay, this is mine now. I'm legally entitled to live here, to do what I want with it within reason, and I pay a monthly fee or a weekly fee for it. Domains are a lot like that too. Like any domains you buy will be like $5 a year, $10 a year, something like that. Which is why I've been curious too, because I don't actually know anyone who buys a domain. They technically rent it. Where things do get tricky though is like sometimes people will like not only pay for the domain hiring, but they will also, domains like google.com or youtube.com, most of you know that, but just realized I missed that. Sometimes you have to pay the person who's currently renting it. So it'd be like, imagine if you went up to like a random house in Randwick and you're like, that's a nice house. You knocked on the door and there's like a family there. You'd be like, I want to live here. And they're like, we live here. And you're like, I'll give you $10,000. And they're like, that's a great deal. We'll go live somewhere else. You still turn up and you have to pay the landlord the rent, which is the company that owns the domain. But you then have to pay the person who previously owned it. That's only really common if like you're a company trying to start, like, there's been cases of this in Silicon Valley where a company thinks, I'm going to start a company called wallet.com. And they're going to big new startup, and then they pay some random company like $500,000 for the domain. But yeah, you can always like look up domains. Like GoDaddy is pretty common with it. Sometimes there's it's funny. Like I have like a couple of domains. One of them I have is like from an old little idea me and my friends had, which was this little app we wanted to build. It was called Collaborate, and I always thought it was like a funny little name, like a play on Collaborate. And I've been paying $10 a year for it for like the last 7 years, hoping that someone one day will be like, that's really valuable, can I buy that off you? That's never gonna happen, but it's a funny thought. But let's imagine we wanted to like be like 2hack.com. You can just search it up and they'll usually be it's free or it's not free. In this one here, you can see that someone actually has 2hack.com, but they don't have 2hack.com.au. So if I go to 2hack.com, sometimes it's nothing. Oh, there you go. That actually is Kahoot. So what Kahoot have done in this case is they bought 2hack.com and they programmed their server to redirect you to another website in this particular case. Sometimes people do that too, like my company I showed you before. We also have like a .au, and if you go to that, it just redirects you, I think. Unless it does nothing. Maybe we've never set that up. But we have lots, oh, we did, okay. It's just slow for some reason. But yeah, you could look up really random ones. Is the screen frozen for anyone else? Oh yeah, that's weird. Wow, that must have been frozen for a while. Let me just fix this quick. Not sure. Strange. Not sure what that was. Yeah, so you could look up all kinds of random things there. And I'm trying to think of a good example. Someone give me a funny website name.
You could search your name.
Yeah, I could. My name's kind of generic. Does anyone have like a cool random name? Like a last name? What about Yuchao? We'll do Yuchao. I'm not aware enough as to how common that name would be. There you go. I hope I spelled Yu Chao's name right. Yeah, so this one's saying that you can buy Yu Chao Jiang. How do you pronounce that name? Jiang. You can buy Yu Chao Jiang for 50 cents for the first year, and then $40 for every year after that. I hate how they do that. So, and they're saying only with a 3-year term. So they're basically saying to you, you can buy it and you can rent it for 3 years if you pay $80.50. You commit to that. But they're trying to advertise it as like 50 cents on year 1 and then $40 on year 2 and year 3. But you could buy that if you want to. And that's a very separate thing from having a web server on the internet, because anyone can have a web server on the internet, but that's just typically an IP address. So like every website has an IP address. Like, I don't know, Google website IP, maybe we can see one. That's their DNS server, isn't it? Or is that their website too? Yeah, that's their DNS. I won't get into that, but you can type an IP address in and end up at that. Sometimes really simple websites like UNSW, if I ping it, I get that IP. If I go to that IP on the thing, maybe I'll get their website. Nah, they don't do that. A lot of websites won't let you do that. They'll like block it and be like, I don't know what you're up to, but I don't like it. But all domains are just pointers to IP addresses on the internet. That's all they are. Is that good? Okay, excellent. Any other questions? YouTube chat. I swear that YouTube, the screen must have been frozen for minutes and everyone on YouTube was just vibing to nothing, I guess. Okay, well, hopefully that was informative. If you do have any other questions, obviously, I'd like to say email me, but I'm not running the course. So post on the forum. We have lots of great tutors who've done this before. Nearly every tutor in the course has done this project by this point or taught it multiple times. There's basically no tutors who haven't taught this or done it before. So they should be really helpful. Otherwise, have a great day. And I think I'm back in week